The sun beat down on the Eurotas, its currents a deceptively swift barrier. 10,000 Spartan warriors, a formidable mechanism of disciplined force, stood arrayed before a significant hydrological obstacle. The challenge was clear: how does such a large, heavily armed body of men traverse a substantial river without the benefit of constructed infrastructure, a bridge? The Spartan military doctrine prioritized efficiency and self-reliance. Unlike other Hellenic states, their logistical train was lean, intentionally devoid of extensive engineering units for rapid bridge construction. This absence was not an oversight but a calculated variable within their operational calculus, demanding inherent adaptability from the individual soldier. The rivers of Laconia, while not always immense, presented varying depths and currents depending on the season and recent rainfall. A river crossing was not a mere inconvenience but a tactical vulnerability, exposing the phalanx to potential disarray and enemy attack during the most fragile phase of movement. The Spartan warrior's gear, while heavy, was designed with a certain utility in mind. The bronze aspis, a circular shield, measured approximately 90 centimeters in diameter and weighed around 7 kilograms. Its convex shape and rim provided an inherent buoyancy, a factor systematically exploited during waterborne movements. Prior to any crossing, reconnaissance elements would assess the river's depth, current speed, and bottom composition. Ideal crossing points minimized risk, seeking shallower fords or areas with slower flow. This empirical data informed the tactical plan, optimizing the flow of men across the natural barrier. The system employed for large-scale river crossings was a testament to Spartan discipline. The phalanx, normally a rigid combat formation, would segment into smaller, manageable units. Each warrior, stripped of unnecessary gear, would prepare for the immersion, ensuring weapons were secured and valuable items were waterproofed. The heavy aspis shield played a crucial role. Held by the warrior, it functioned as a primitive flotation aid. By gripping the shield's interior straps and allowing its convex surface to trap air, a soldier could leverage its buoyancy, transforming a potential drowning hazard into a controlled, if arduous, transit. The crossing was often executed in a tactical formation, even within the water. Soldiers would link arms or maintain close proximity, creating a human chain that could resist stronger currents more effectively than individual swimmers. This communal effort reduced the risk of a warrior being swept downstream, maintaining cohesion. Leading the crossing often were the most experienced and physically robust warriors. Their role was to establish a secure path and act as anchors against the current, guiding the less experienced across. This hierarchical distribution of labor ensured a controlled, sequential traversal rather than a chaotic rush. The heavy bronze armor, specifically the cuirass and greaves, presented a significant challenge. These components, while offering protection, would severely impede buoyancy and movement. Warriors would typically shed most, if not all, of their heavy metallic armor before entering the water, carrying it carefully to the opposite bank. The removal and redonning of armor were highly coordinated movements executed with precision. Specialized personnel might assist in the rapid collection and distribution of gear on both banks, minimizing the time the phalanx spent in a disarmed and vulnerable state. Speed was paramount. Upon reaching the opposing bank, the immediate objective was to re-establish the fighting formation. Warriors would quickly rearm, reform their ranks, and secure the landing zone. This rapid reconstitution of the phalanx ensured that any potential enemy engagement could be met with organized resistance. The entire process, from approach to reformation, was a drill rehearsed countless times during the agode and subsequent military exercises. The fluidity of transitioning from land march to river crossing and back to combat readiness was a testament to the rigorous, repetitive training imposed on every Spartan. In contrast to the Spartans, other armies might construct temporary pontoon bridges using rafts or timber, a slower and logistically intensive process. The Macedonian army, for example, under Philip II and Alexander, famously employed engineers for elaborate river crossings, showcasing a different tactical philosophy. The Persian Empire, with its vast resources, often relied on monumental engineering feats, constructing bridges of boats for massive armies, such as those famously employed by Xerxes for the Hellespont. This contrasted sharply with the Spartan ethos of minimal logistical overhead and maximal individual soldier capability. The Spartan method, while efficient for swift deployments and minimizing supply lines, inherently limited the types of terrain and obstacles that could be overcome without significant delay. A truly vast or exceptionally turbulent river could still pose an insurmountable barrier, forcing long detours. The psychological impact of such a crossing was also a factor. The shared vulnerability and collective effort reinforced the bonds of the phalanx. Each warrior was dependent on the discipline of his comrades, strengthening the cohesion that was the hallmark of Spartan military effectiveness. However, this reliance on innate soldier capability and the lack of dedicated engineering units exposed a systemic rigidity. The system was designed for the individual Spartan warrior's prowess, not for adapting to novel or extreme environmental conditions outside their practiced parameters. As the scale of warfare evolved and conflicts moved beyond the Peloponnese, the limitations of this self-reliant system became more apparent. The need for advanced siegecraft, complex logistics, and varied engineering solutions began to outpace the Spartans' austere, soldier-centric approach to obstacles. The unwavering focus on the individual soldier's physical and mental conditioning while creating unparalleled warriors also meant an underinvestment in support technologies and specialized skills. This structural imbalance would eventually contribute to the strategic inflexibility of the Spartan military machine. The population decline of Sparta, exacerbated by wars and the inherent rigidity of their social system, further eroded their ability to field large, adaptable forces. Fewer men meant less capacity for even simple tasks, let alone complex engineering solutions for river crossings or other logistical challenges. The reliance on the individual soldier's innate capability for river crossings, while fostering extreme self-sufficiency, also imposed significant operational constraints. It meant that major campaigns into territories with numerous large rivers were logistically challenging and resource-intensive, often leading to strategic avoidance. This operational rigidity stood in contrast to rising powers like Rome, which integrated sophisticated engineering corps as fundamental components of their legions. Roman armies could construct pontoon bridges or even fixed bridges with remarkable speed, enabling rapid and secure passage over virtually any aquatic barrier. The Spartan system, therefore, optimized for a specific set of conditions, disciplined infantry combat within a familiar geographical sphere where rivers were manageable. Beyond these parameters, the lack of adaptive infrastructure became a critical limiting factor, hindering grander strategic ambitions. The philosophical underpinning of Spartan society, which devalued manual labor and innovation outside of military training, prevented the development of specialized engineering knowledge. This intellectual and social rigidity ultimately constrained their military's adaptive capacity in a changing world. Without the capacity to rapidly overcome major geographical obstacles, the Spartan military machine was effectively tethered to its immediate environment. This forced a strategic conservatism that became increasingly detrimental as other polities developed more flexible and technologically advanced approaches to warfare. Thus, the question of how 10,000 Spartan warriors crossed a river without a bridge reveals not just their physical prowess, but also the intrinsic limitations of their military system. It was a method built on human endurance and discipline, rather than on evolving technological solutions. The Spartans' approach to river crossings, while effective in its context, ultimately highlights the trade-off inherent in their rigid military specialization. Their strength was also their vulnerability, a system designed for a specific kind of conflict that eventually became obsolete. The operational paradigm of the Spartan army, though highly effective in direct combat, was ultimately rigid. This inherent rigidity meant that complex logistical problems, such as overcoming significant natural barriers, were addressed not through innovation or engineering, but through sheer individual and collective endurance. This mechanical system, built on the human component as its primary tool, offered unparalleled efficiency in specific scenarios, but lacked the adaptive capacity to meet the evolving demands of Hellenic warfare. The Spartan river crossing method became a symbol of both their strength and their strategic limitations. The sun now sets over the Eurotas, its currents flowing onward, indifferent to the historical systems that once sought to conquer its flow. The river, a constant, witnessed the disciplined movement of the Lacedaemonians, a fleeting moment in the long history of military engineering. The meticulous training and psychological conditioning that allowed 10,000 Spartans to cross a river without a bridge underscored their military's core principle. The warrior himself was the primary instrument, yet this very focus precluded the development of the auxiliary systems that would define future military successes. The Spartan system, for all its unparalleled focus on the individual warrior's prowess, ultimately demonstrated the critical distinction between optimizing the human element and integrating diverse technological and engineering capabilities into a holistic military machine. One was not a substitute for the other. This method of river crossing, a testament to discipline and raw human capability, asks us to consider, what is the true cost of perfection when that perfection is achieved through singular, unyielding specialization rather than through adaptable, multifaceted innovation?